All right, so I'm going to go ahead and I'm recording now, so this will be uploaded to Blackboard to YouTube for you to review later on. Again, if you are just joining us, please type into the chat your full name and the campus that you are from. So like if you put your name in but didn't put your campus, please put your campus there too, because your instructors are asking for that information. So, all right. Couple things. For Allegheny campus, these are the things you need to know and memorize. You should already have those memorized. For any of the other campuses, you're also going to need to know, and you probably already know these already. 1 cup is 8 ounces, is 240 milliliters. 1 pint is 2 cups, is 16 ounces, is 480 milliliters. And then 1 quart is 2 pints, which is 4 cups, which is 32 ounces, which is 960 milliliters. And I think at this point, you all know that. So if you do have a question, please either raise your hand or just unmute and stop me. If you type it into the chat, I'll see it. If you're concerned that you might ask a question that you feel like might not be a smart question, and that's your interpretation, not mine, you can send it as a direct message. That way I'll see it and I won't say, Deborah said. I won't say your name. Okay. All right. So let's just get into this, because I think most of you know these things. You're going to see a lot of questions that are going to be similar to what you saw in second semester. You're going to see some additional questions that have to do with heparin. Okay. So before I get into the heparin protocol, and by that I mean there's a couple of things that are a little bit different between the different campuses. So, but I'll show you what you need to know for Allegheny campus, or what you might see. And then, but for both campuses or all campuses, knowing how to go from units per hour to milliliters per hour is a big chunk of what the heparin protocol is. Or anytime you see heparin infusions or doing something with heparin, a lot of times what they're asking you to do is just to convert units per hour to milliliters per hour. So let me work through 22 and 23 so you can see what those types of questions look like, give you a couple other examples, and then for Allegheny campus, show you the heparin protocol, which would be helpful for you at Boys South North, but you'll most likely see it at Allegheny. Allegheny. Okay. So first things first, we have an order of 0.45% normal saline, 1,000 milliliter IV with heparin 25,000 units. Then it says it's infusing at 1,000 units per hour. And then it says to calculate the flow rate, but they want to know, when they say flow rate, they don't want it in units per hour. They want it like it would be put on the infusion pump, which is going to be milliliters per hour. Now, if you're ever looking at this and like, well, how do I know, because people always say they get put on a heparin drip. How do I know it's not a drop rate? Well, there would be other information if we were looking for drop rate. There would need to be a drop factor, like 15 drops per milliliter, or it would need to tell you it's in microtubing or something along those lines. If it doesn't say any of those things and they're looking for flow rate, milliliters per hour is what you're looking for. Okay, couple things. This 1,000 milliliter IV has the 25,000 units of heparin in it. They're together. They are your, for lack of a better term, conversion factor. Very similar to like where I would say like a Dilantin suspension is 125 milligrams per 5 ml. This is 25,000 units heparin per 1,000 ml. Okay, that's how you look at it. This is your infusion rate, 1,000 units per hour. So we want to keep those two together, but we want to work with them apart. So let me show you what I mean by that. So this question, you can learn a strategy just by kind of following along with what I do, or if you apply dimensional analysis technique, it helps to kind of keep things simple. So one of the things, at least for organizing the material, so one of the things we're looking for is what is the flow rate in milliliters per hour, okay? We have a current flow rate of units per hour. So what I'm going to do is I'm actually going to start with my current flow rate, which is the 1000 units per hour. And I'm going to write it as if I'm writing out dimensional analysis. Okay. So 1000 units per hour. So the question is, I don't want units per hour. I want milliliters per hour. So I'm going to leave the hour alone. Don't mess with that. That's fine. Okay. But I want to know, can I get rid of units or convert units to milliliters? So can I do that? And the answer is yes, you can. It's right here. You have 1000 milliliter IV that has 25,000 units in it. So all I'm going to do is I'm going to put the numbers with the units that they go with. So units has 25,000 units and milliliters has 1000 milliliters. So again, and I say again, just because I've already said this a couple times today, but the benefit of doing dimensional analysis is that it helps out with kind of making sure you have a plan and making sure that you're able to eliminate units and be left with what you're looking for. We're looking for milliliters per hour. Okay. So I'm going to take the 1000 units times 1000 milliliters. So 1000 times 1000. I'm going to divide by 25,000. And I'm going to get an answer that probably seems a little bit more realistic of 4 milliliters per hour. So I didn't have to convert minutes to hours. I didn't have to do anything other than convert units per hour to milliliters per hour. So my strategy doing these types of questions, and this is essentially what you're doing when they talk about heparin questions, is just making a conversion of units per hour to milliliters per hour using my available IV as my available, okay, or as my as my available. So you'll notice it's like it's not really there's an order here. It's just what is the flow rate in milliliters per hour versus units per hour. I'm going to do the same thing with number 23. Number 23 says that I have a 500 milliliter IV that has 500 units of insulin in it. And then they add the extra U100 insulin. So it makes you think, you know, how many numbers do we need to include in this? But my IV is 500 milliliters, 500 units, and it's infusing at 10 units per hour. So I'm going to follow the same strategy. And the reason I'm showing you this again is just because if you ever get stuck, like if you know to do 10 times 500 divided by 500, or in the previous one, 1000 times 1000 divided by 25,000, as long as you know how to do that, you're doing it right. You just aren't explaining it the same way I am, which is not a problem. No one asked you to necessarily explain anything. But if you're ever wondering, like, why do I get this right? Or why am I getting this wrong? If you happen to get it wrong, this hopefully will help you figure out where you might be tripping up. All right. Remember, we're getting rid of units in exchange for milliliters. 500, 500. Those happen to cancel out. So my 10 units per hour is the same thing as my 10 milliliters per hour. It doesn't always work out that way, but that's just how it worked out for this particular question. Sometimes seeing the simple version is what is helpful for understanding how to solve the more complex type versions. Now, I want to pull up like a similar question on the other review. So give me a moment.
I just had a quick question about number 24, because we were asked to write our times in military time. And when you just look at the answer for 24, it just says 4 a.m. So should we still, when we're doing our quiz, make sure to put that as military time?
Correct. Yeah. So you would just write it as 0400.
Okay, thank you.
You're welcome. And I just want, okay, so I'm going to show a variation of this heparin question. That is what you'll see similar to what I'm going to show the Allegheny campus in just a moment. If 21 is the, yeah, so 21, just pick the strongest concentration. So 350,000 divided by 1,000,000, and that's your answer, 0.35. But I'll come back to that if we need to. All right, so let me go through these heparin questions because there's a couple. So first of all, here's a very similar question that I just went through. It tells you what's available and what you're infusing at. So these are specifically Boyce questions, but they're good practice for really any Allegheny campus, any of the other campuses. But sometimes they're helpful to look at what these are without all the extra information. What I mean by that is, if I go back to my practice test for 220, 230, you're going to see all this extra stuff for the heparin protocol. And it's going to be like, what is all this stuff? And I'll explain that in just a moment. But what Maddie did is she actually put together a review that like made this a little bit more concise. So if you want to come back to this and be like, oh, okay, I can look at it this way, or I can look at it like the other way. There's a couple different ways that you can do this. So for this question, this is actually the same question that I just showed you on the other screen, or the other document, is doing a heparin infusion. So heparin infusion involves a couple of steps. It involves accounting for the patient's weight, converting pounds to kilograms, multiplying by the patient's weight in order to get the number of units for a bolus dose, as well as calculating the number of milliliters for a bolus dose. And so we need some pieces of information from the heparin protocol. Sometimes they're easily given to you like they are here, which is why I'm starting with this. And then sometimes you have to kind of figure out where they are, especially if you're at Allegheny campus, and that I do take partial, if not complete, responsibility, because I could have easily just written the questions a little bit more concisely. But anyways, sorry about that. All right. So for this question, we are going to do two things. So notice it says, it actually says 4 questions, but we'll get to the other questions in a minute. There's 2 questions here. Sorry, I like to use red. There's 2 questions here, A and B. A is calculate the number of milliliters to administer for the bolus dose. And then B is calculate the infusion rate in milliliters per hour for the heparin IV drip. Now, notice they use that word drip. That doesn't necessarily refer to drop rate. Okay, but that's where I think some of this terminology gets a little bit confusing, especially if it's the first time going through some of this. So the first thing I'm going to do is I'm going to take the patient's weight and I'm going to divide by 2.2. So you can write that however you want. And I think I'm going to get 50 kilograms. Yeah. Which is 50 kilograms. Just one second. I just want to double check something here on my screen. And get, okay. All right, so 50 kilograms. So now I have the patient's weight in kilograms. Now what I can do is I can look at where the protocol tells me to bolus the patient with 80 units per kilogram body weight. So 50 times 80. And then it says to start a drip at 18 units per kilogram per hour. Okay, that's what the heparin protocol is. Give them a bolus dose and then start them on an infusion. Okay, so for calculating the bolus, okay, so this is going to be A. Just put A right here. Okay, so 50 kilograms. I'm just going to multiply by the 80 units per kilogram. Now, this is a multiple step process. You can certainly simplify this, and I'll show you how I would simplify it in just a moment. But I would just take 50 times 80, and I'm going to get 4,000 units. Now, the question says to calculate the number of milliliters. So I need to find a way to convert units to milliliters. So I have two availables. I have a heparin 25,000 units and 250 milliliter half normal saline. So that's my IV. And then I have a bolus dosage strength available of 1,000 units per milliliter. So I basically have two availables. One's for the bolus dose and one's for the drip or the flow rate. So I'm going to use the bolus dose since that's what I'm calculating. So I'm going to set this up like this. I'm going to convert units to milliliters. 1,000 units, 1 milliliter, and my answer is going to be 4 milliliters. If I wanted to simplify this, the way I would simplify this is I would find the patient's weight in kilograms, because that's the thing that's going to change, right? So on your test, you're going to get a patient that weighs a certain mass, a certain amount, usually in pounds. So you have to find it in kilograms. I would advise you to round to the nearest tenth, then proceed with the rest of your calculations. Kilograms, then you're going to multiply by 80, divide by 1,000. Okay. If I wanted to like just simplify how to do the heparin bolus, at least the initial bolus, multiply by 80, divide by 1,000, and that will give you your milliliters. Okay. I'm giving you the very simple form because it'd be helpful to just kind of check your work just by plugging in the patient's weight in kilograms, multiplying by 80, divided by 1,000, and then you should get the same answer as if you wrote it out the long way like I just did. What happens if you get something like 4.45 milliliters? Round to the nearest tenth. Okay. Part B, I'm going to do the same thing. I'm going to take, it tells me to calculate the infusion rate in milliliters per hour for the heparin IV drip. Well, how do I get to even utilizing milliliters per hour? So I start back up with the protocol. We already did the bolus. Now we're going to start a drip at 18 units per kilogram per hour. Remember, we're talking about the same patient. So we're going to use the same patient weight of 50 kilograms. But instead of 18, this time we're going to multiply by, or 80, we're going to multiply by 18. And this is units kilogram per hour. When I do that, 50 times 18 is 900 units per hour. So those of you at Allegheny campus, this is actually question 25. It's just a simplified version of what it looks like. And I'll show you what this looks like on the protocol itself in just a moment, but I'm solving the math associated with the protocol by following this. So again, remember how we did a couple problems just a few minutes ago? Yeah, a few moments ago about units, converting units per hour to milliliters per hour. There was a secondary reason why I started with units per hour is because you're going to see that when you do these heparin protocols. Do I know how to convert units per hour to milliliters per hour now? Yes. And then, you know, with practice, you'll get there too. But my numbers are going to be a little bit different, right? So it's not going to, it wasn't written in the context. It's written in what my availables are. So my availables are, I have 25,000 units, 250 milliliters, half normal saline. So I'm going to put my 25,000 units here. And I'm going to put my 250 ml right here. I'm going to do 900 times 250 divided by 25,000. I'm going to eliminate units because I want to make sure I'm in milliliters per hour, which I will be. Here I was in milliliters. Here I'll be in milliliters per hour. And I'm going to get 9 mil per hour. Now, just for simplistic sake, this is the same thing as 1 over 100. So if this is for calculating bolus up here, the short for the drip, it's going to be patient's weight times 18 divided by 100. And that'll give you milliliters per hour. Same thing as before. If if you get 9.76, 9.8 milliliters per hour, round to the nearest tenth, it may not make sense in the context of what you would actually put in the infusion rate, but based off of what it says in the blueprint, it says you would round those numbers to the nearest tenth. Now remember, this is all being saved. It will be uploaded on YouTube later today or tomorrow, and then it's also being added to your it's added to the OneDrive folder with my writing on it. All right. This question here, it's in the link that so someone asked, how do you access the OneDrive folder? It says click here for practice tests. It's that link. And if you didn't get it, I'll email it, or I'll give you my email address in the chat. If you didn't get the review information, just email me and I'll make sure you have access to the OneDrive folder. All right. So notice that this is basically the same question, the 18 units per kilogram per hour, but this time they gave us the patient's weight already in kilograms, so I don't need to convert anything. And then it gave us a different IV infusion, 500 milliliter bag, 25,000 units. And then we just want to know what the infusion rate is, which is milliliters per hour. So what I'm going to do with this is I'm going to start off just like I did previously. So 75 kilograms, patient's weight, times the 18 units kilogram hour. That's going to give me, so 75 times 18 will be 1,350 units per hour. I'm going to multiply by my conversion. So I don't want units, right? But I do want milliliters. I'm going to look at my 500 milliliter bag that has 25,000 units heparin in it. So 25,000 always seems to be 25,000. But this time it's 500 milliliters, so it's not 250. So those 1 over that, divide by 100, divide by 1,000, that's specific for that question up there. And then, and I'll show you what I mean by why that's important in just a moment. So I'm going to take the 1,350 times 500 divided by the 25,000. And I'm going to get an answer of 27 milliliters per hour. All right, I'm going to do the next question, but I'm actually going to go back to the Allegheny campus review guide. All right, so in the previous question that I did, remember it was a patient was 110 pounds, right? The protocol said 80 units per kilogram body weight for the bolus, and then to start a drip, right, at 18 units per kilogram per hour. So that's how that was written in the previous example. But then you also notice that if you are looking at the Allegheny review, that there's all this extra information. And that's because this is, if you do a Google search for heparin protocol, this is what it looks like. It's basically a sheet of directions that encompasses not only math, but also other things. Now you'll notice that I edited this where I crossed out basically all of this. Okay. I just crossed it out because it's not what you need in order to do what we're doing here for the math component. Okay. So we can just go ahead and just ignore that section. Okay. But notice that it repeats the protocol, right? Bolus with 80 units per kilogram, start a drip at 18. Then it also tells us what we have available. Heparin, 25,000 units, 250 milliliters, half normal saline, with a bolus dosage strength of 1,000 units per milliliter. So it gives us that information, just like it did in the previous example on the Boyce study guide. It just gives us a different representation of that. Okay, so this is where we're actually going to do the same question that we did before. That was the next question in line in the previous thing. It's just it's here. Okay, so we actually already did on the previous sheet. We did this. This is where we got the 4 mil and then the 9 mil per hour. That's what we just did previously. Okay, so I'm going to show you the same steps, but I'm just going to work through the second 2 questions. Now, for Allegheny campus, you need to be prepared to either answer these 2 questions. So you're either going to answer these 2 questions, and that'll count as 1 question, or these 2 questions that'll count as 1 question. Okay. So if you miss one, or if you miss them both, you've only missed 1 question. Okay. You don't get half points or anything like that. But if you practice these, you won't miss them. Okay. All right, so the second part of the heparin protocol is where we assess our patient and we see and we test and evaluate their clotting time, so the APTT, and we're looking to see, what that is. So in this example, it's 43 seconds. Okay, so what I'm going to do is I'm going to look at my protocol, or it'll be stated for you like it was in the Boyce review. And I'm just looking through the different portions of the protocol, and I look to see, what do we do with an APTT of 43 seconds? And that's why I highlighted this, right? Because 36 to 44, 43 fits in the middle of that. And we're going to do what it tells us to do. It says to rebolus with 40 units per kilogram, and then to increase our infusion rate by another 2 units per kilogram per hour. So our initial bolus was 80 units per kilogram. Now we're going down to 40 units per kilogram. So if you're sitting here going like, oh, okay, I can do that. That's 2 milliliters. Great. You did that right. But as a refresher on how to answer that or solve that, let me write it out. Okay. So I'm going to take our patient. Remember, it's the same patient, 110 pounds. So there's still 50 kilograms. That did not change. Okay. The only thing that did change was now instead of 80 units per kilogram, now we're doing 40 units per kilogram. Cross out kilograms. And now I'm going to get 2,000 units. Then I'm going to multiply by my bolus dosage strength. Remember, if we come up, our bolus dosage strength is this right here, the 1,000 units per milliliter. I just want you to know where I'm getting my information from. So 1,000 units per milliliter. So how do I know, how do I know to put the units down here versus up here? You hear me saying units per milliliter, but then I'm clearly writing it inversely. Well, it's how we canceling these out. That's a good way to kind of remember where to put it. Or if you're doing this ordered over half, and you've done that plenty of times, you're just doing 2,000 over what you have available, 1,000, and then times the quantity, which is 1. But we're going to get the same answer, 2 mil. Same answer that we got up here. Then it says to calculate the new infusion rate. Okay. And I think most students are fine with the bolus. It's the infusion rate that can sometimes be challenging. And I will say one of the things that is challenging too is knowing what to do with this 2 units per kilogram per hour. Okay. So we're not going to calculate 9 milliliters per hour, then do something of the 2 units per kilogram per hour. We're just going to come back to the beginning of the problem. And remember, the beginning of the problem told us what? It told us to start a drip at 18 units per kilogram per hour. So if we're increasing by 2 units per kilogram per hour, that means we're going to go from 18 now to 20. So I'm going to take the same patient, same weight, 50 kilograms. And then instead of 20 unit or 18 units per kilogram, I'm going to do 20 units kilogram per hour. I'm going to get 1,000 units per hour because I got rid of kilograms, right? And then I'm going to convert units per hour to milliliters per hour, again, using what we have available. What do we have available? Heparin, 25,000 units, 250 milliliters, half normal saline. So I don't want units, which is why I write it down here. Do want milliliters, 250, 25,000. And I'm actually going to get an answer of 10 milliliters per hour. So the trick or the secret is just, especially if you're at Allegheny campus and you see this especially for the first time, see this monstrosity of a protocol, it's very challenging. And you're sitting there going like, what in the world am I looking at here? Now you know what in the world you're looking at there. You're just basically looking at like what would be like the equivalent of a poster in the back area where you might be, or in the room where the patient might be receiving a heparin protocol, and it just, or it's on your, you know, on your screen. I almost said on your clipboard. I think we're past that point, right? But in your chart, right? However you're receiving that chart, you're seeing this information and you're just following the protocol. I think the way that Maddie put it together, organized it, is actually a little bit more concise, and maybe we'll migrate towards that at some point in the future for Allegheny. If they ask me to rewrite some of the tests, then I'll do that. Okay. So again, when you see this on your test, don't try not to get worked up about it. Just know that you're going to see you're going to see these questions in a variety of different ways. But you know, even though there's 4 questions listed here, you're only being asked to calculate the bolus and then the flow rate. And I think that's the same for voice as well. And it'll be just like what I showed you with the other review. I'm going to come back to this. I just wanted to address, because someone had asked about question 21, and then I briefly went over it. I just want you to know, like, you know, when you see a question that looks like this, and this is what if you look at a Pfizer pen label, you'll see this. Oh yeah, so someone asked if the content, so 220, 230, as far as I understand, they're the same skill test. It's just that you might be taking 220 before 230 or vice versa. So it's the same test. As far as I know, it's the same test. The only thing that's different, like for third semester, I think you guys do third semester, I think you have pediatric dosage this semester. So there is a separate test, at least at Allegheny campus, there's a separate test for pediatric dosages, but that's not this test. All right. So if you pull up the label for Pfizer pen, you will see where it tells you, this just tells the pharmacy, or maybe even you, if you're working in a clinical setting where you have to add dilute or sterile or deionized water. But for calculation purposes, we just ignore that section. And I'll show you that also for voice on the reconstitution question. And all I care about is the strength. Okay. So here it told me to choose the strongest concentration. My order is 350,000 units. My strongest concentration is 1 million units per milliliter. So I'm just going to take my 350,000 over my 1 million units. And I'm going to get an answer of 0.35 milliliters. And then there's a chance that I actually have the key wrong for this one. Oh no, it's 0.35 milliliters. In the past, I've had the key incorrectly written, only because it was still left at like a previous variation of that question. Okay. The Boyce equivalent for this question, and I think at this point, Boyce students have seen these enough times. Hopefully this isn't a shock, but your reconstitution question is going to look more like this ANSEF question, right? So it'll tell you, you have an order of 0.375 grams intramuscular, and then it's going to ask you how much would you administer, and you might be wondering, well, how do I know how much I'm going to administer based off of, is it tablets, is it capsules? Okay, so somebody asked me for Allegheny. Yeah, so what I'm going over is for the test that you're going to have next week, first thing. If you are taking pediatrics this semester, which, like I said, I think you are, you'll have a separate test during the pediatrics semester that you'll go through and do pediatric dosage calculation, but it's not this. Okay, so what I have put together for all of you is this is what's on the OneDrive folder is for the test that you'll be taking next week, not the pediatric one. And I from what I remember, it's third semester. I don't think it's second semester, but I think it's third semester. I just don't remember when that is. But they'll tell you when you have your pediatric math test. That'll be after learning about pediatric. And if you're wondering, yes, I do on my YouTube channel. I've gone through some of the review questions for pediatric. So you can look at those if you need some additional help with that when you get to that point, but it's not for next week. All right. So for this question, a couple things and how we know if it's a reconstitution. A lot of times reconstitution will just tell you that it's 500 milligrams. It doesn't give you any kind of volume associated with it. So like I always go back to the example of like Dilantin. Dilantin is 125 milligrams per 5 ml. Okay, for that strength of Dilantin. It tells you the per milliliter, but in the when we're dealing with a reconstitution problem, and again, this is more for Boyce. This is not necessarily what you would see at Allegheny campus, but at least not yet. And so when you know that, now you know to look, when you know that you're dealing with a reconstitution, now you know to look at the side image. Okay. So it'll give you like a usual adult range, 250 milligrams to 1 gram is the usual. It'll tell you to add 2 milliliters of sterile water. So this ANSEF is actually powder. You open it up. Usually it's done in the pharmacy, but if you're working in a clinical setting where you're the one doing the mixing, you would just add sterile water to the powder, mix it up, okay? And that'll give you an approximate total volume of 2.2 milliliters, okay? But you don't really need to know that if it gives you the concentration, which is what I've circled right here. It tells you that the available is 225 milligrams per milliliter. You don't need to do anything else with that. If you wanted to, or if it didn't tell you the 225 milligrams per milliliter, that's where you would take the 500 milligrams, divide it by the 2.2, and you'd actually going to get 227.27 repeating. And so what they did is they rounded that down and estimated at 225 milligrams per milliliter. Okay. But the actual concentration of this, assuming that the volume is actually 2.2 milliliters, is more likely 227 milligrams per milliliter. That's just an FYI. So I'm not writing it down. It's just so you know where that's coming from. But this right here, so I wouldn't even worry about this. I don't worry about the 2 milliliters being added. All I care about is the 225 milligrams per milliliter. And then that's what I used to solve this, right? So I converted 0.375 grams to milligrams, divide by 225, and I get an answer, and I think it was rounded to 1.7 milliliters. It's a good question. So someone asked if there's another name for reconstitution. If it's not in your blueprint, then you may not have it, but you've had it before, so it's worth reviewing. Because it will probably be on your 4th semester test if you see it. But you did reconstitution 1st and 2nd semester, so it's to my knowledge you might have it on the 3rd semester test. Because like I said, the 220 230 blueprint, as far as I know, it's the same blueprint. I can actually pull that up and I can tell you if it's the same blueprint, because I actually have that. Give me one moment. Since you asked, I just want to make sure. So I thought I had it. Oh yeah, it's in the 110 folder. Maybe I have the blueprint for everything somewhere else. So give me just one moment. Oh yeah, that's 110s. Just give me one moment. Promise. Okay. Oh, never mind. I thought I had the blueprint listed here, but the blueprint should be, if it doesn't include the reconstitution, then you don't need to worry about it. But like I said, you might eventually see it again anyways. So that's why I didn't think it was harmful to revisit that. But you might see it again. Just thought I had it listed somewhere, but I don't. So all right. Do you have any questions or any particular type of question that you'd like to see work through? You can, like I said, you can just you can unmute, you can just type it into the chat.
Dr. Rad,
Yeah.
I have a question. At Boys Campus, they always put questions on our Med-Calc exam with the electronic infusion pump. And it won't even be like an actual question. It'll just say, here's the order, here's what you have, and then you have an electronic infusion pump. Now solve for that. And I'm always confused, like, how do you know what the answer is supposed to be in? Like, if it's supposed to be in drops or like the mLs per hour.
Okay. So good question. I don't know specifically, but here's a couple things I would look for. If it doesn't tell you anything, like if it doesn't say microtubing, and if it doesn't give you a drop factor, meaning it doesn't tell you like, look at the label, or there's a picture where it's telling you like, some sort of drop factor, which is drops or GTT per milliliter, then it's going to be in the, you're going to be looking for milliliters per hour. But if it does give you like microtubing, if it does give you a drop factor, then you can assume that you're going to be calculating an infusion rate in drops per minute. So that's what I would use, like the context of the question, that's how I would factor that in. And I thought
That's actually really helpful.
Okay, good. Yeah. So, I mean, that's how I would look at it. And then that way, because like I said, from what I understand, there's only 2 possibilities. It's going to be milliliters per hour, or it's going to be drops per minute. And you can't calculate drops per minute off of a whim. You have to have other pieces of information, microtubing, or they'll give you the number.
Okay, thank you.
Yeah, you're welcome. Good question. Thank you for asking it.
Dr. Red, I have a question.
Yes.
About the heparin protocol, but it's nothing. It's just about the rounding.
Yeah.
So the first things we did, we converted pounds to the kg. So what we if get 50.467 kg instead of direct 50.
Say that one more time.
So the first things we did, we converted pounds to the kg, and we got 50 kg, right?
Correct.
So what if we get 50.467 kg?
Round to the nearest tenth is my recommendation.
So it's gonna be 50.5.
Correct.
And what if we get 50.015?
I would just leave it at 50. Because you care about that 10th place if it's significant. And what'll happen is if let's say you don't do the rounding, and I've done this a couple of times, if you don't do the rounding and you wait until the very end of the question, your answer is going to be the same. Or at least more often than not, it will be the same. So I always just recommend converting, when you convert pounds to kilograms in your when you're doing the Heparin protocol, go ahead and round that to the nearest tenth and then proceed with the problem. So if you do have like a 50.0125 or something like that, it's just 50. It's, I would tell you the same thing. Like if you got 49.99, it's 50, right? It's close enough. It's 50. Close enough is in regards to when we're dealing with adult infusions.
Okay, thank you.
You're welcome. Good question. Were you the one that raised your hand? Okay.
Yes.
Okay, thank you. I saw a hand go up, or at least I got a notification. I just want to make sure that was you. Okay. All right. So someone asked me to work out.
Dr. Brad,
Oh, go ahead.
do you have a better way of doing number 24 for Allegheny campus? I did mine and sent it to you as a picture yesterday.
Okay.
It's my way of doing putting into the understanding, but I just didn't know if you have a better way for us to solve it.
All right. I'll do number 24. I had someone ask me to do number 27 here, and then I'll come back to 24 on the Allegheny. I'm assuming you're at Allegheny campus, correct?
Yeah, and
Okay.
I was the one who sent you email yesterday.
Okay. Yes, I did get your email, and I was glad that you knew that you didn't miss the review sessions, but I obviously couldn't answer your question, so I'm glad that you're here, and I will answer your question. So just stay tuned. Let me do 27 real quick, and then I'll come back to 24.
Sure, thank you.
You're welcome. All right. So for this question here, it says, in order to lower blood pressure, we're going to use nitroprusside in dextrose 5% in water. It's to be titrated 15 to 200 micrograms per minute. Okay, so that's this is going to be a fun question. The IV solution was prepared by adding 50 milligrams to dextrose in water. The final solution contains a total volume of 250 milliliters. You should infuse the IV solution at a rate of blank to blank milliliters per hour. All right, so I don't know if you're even going to see this as a particular problem, but what this looks like is you're stepping up your infusion rate, right? So you start at 15. So this is the starting point, and you're ending at 200. Okay. So the misconception on this is that you're calculating the in-between. You're not. You just need to know what you start and then what the next bump is. Okay. So the way I would do this is I would put this together like such. So I'm just looking to see. Okay. So it tells me 15 micrograms per minute. Okay. It also tells me 200 micrograms per minute. So the first thing I'm going to do is I'm actually going to do two things. I want to convert micrograms to milligrams, but I'm going to wait on that. I don't necessarily have to do that right now, but I do want to convert minutes to hours. Okay, so I'm going to multiply this by 60 minutes. Same thing here. I'm doing these two simultaneously because these are the two answers that I'm looking for. All right. So 15 times 60 will give me 900 micrograms per hour. And then 200 times 60. It's 12,000 micrograms per hour. So micrograms per hour is very similar to units per hour. It's just another way to write a particular flow rate, but this in this instance, they're doing strength per hour. And so what I want to do is I want to convert micrograms, or I want to convert micrograms per hour to milliliters per hour, since that's what I'm looking for. And I'm going to do that by using the 50 milligrams, 250 ml. So the first thing I'm going to do is I'm actually going to convert milligrams to micrograms, just because these are already in micrograms. So my strategy is I try and do the least amount of switching things around as I need to. And so 50 milligrams is the same thing as 5,000 or 50,000 micrograms. So I'm just going to write 50, 1, 2, 3 micrograms. Okay. Just to double check, 50 times 1,000. Yeah, 50,000. And then 250 ml. So what I'm going to do is I'm going to convert my micrograms to milliliters, which I can do based off of this right here, telling me I put the 50 milligrams in the 250 milliliters. So here's my 250 milliliters. Here's my 50,000 micrograms. I'm going to do the same thing down here. 250 milliliters. 50,000 micrograms. And if you're sitting there wondering, like, how do I know? I have not worked this problem out before. So what I'm using is I'm just relying on dimensional analysis to help guide me to where I want to go. And then I'm deciding what I want to convert, because I could have converted 900 micrograms to 0.9 milligrams, 12,000 micrograms to 1.2 milligrams. I could have done that and then just used the 50 milligrams. But I chose to do it this way. I just want you to know, if you did it a different way, as long as you're getting the same answer, we're probably all doing the same thing. Okay. This is a Boyce campus question, but it's a fun one nonetheless. Okay. So now I'm going to take 900 times 250, and I'm going to divide that by the 50,000. I'm going to get 4.5 milliliters per hour. So that's what I'm going to start the infusion at, is 4.5 milliliters per hour. Then I'm going to take 1,200. Or is that 12,000? Sorry, 12,000. No, it is 1,200. I wrote an extra zero in here, so sorry about that. All right, so 1,200 times 250 divided by 50,000. And that's going to be 6 milliliters per hour. So that's what you would do. You would start the infusion at 4.5 milliliters per hour and then step it up to 6 milliliters per hour. I don't even know if it set a time frame, but you're probably monitoring their blood pressure, and that will ultimately determine how quickly you go or how slowly you go. But anyways, that's how I would do this particular problem. And you'd have 2 separate answers. And then just so you know, if you're sitting there going like, I'm not gonna be able to do this. This is half of what pediatric dosage is you're calculating the ranges, the low end and the high end. And then you want to make sure what was ordered is within a safe range. And so this is good practice for preparing for pediatric dosage. If you haven't, I don't think you've had that class yet. So yeah, you know what? I do believe that that she did say, yeah. So I'll make that correction now. Yeah, she actually, believe it or not, when Maddie put this together and I asked her that I could reuse this, she also she quickly told me that there was a typo and I completely forgot to change some of those. So if you do see something that doesn't seem right, just message me. I'll make sure to try and make sure to make the correction. All right. And then for someone asked, 24, that's right. So let me go back to that. Okay, so yeah, so if you're doing this, like I said, I didn't get to see whomever asked me that. I didn't get to see what you wrote, but this is, I'll just show you how I would solve this. So the first thing you got to figure out is how much time does it take for this to infusion to take place. So you're going to start off with your 1,000 milliliters. And it's infusing at 50 milliliters per hour. Again, the reason I know to put milliliters there is twofold, because I'm trying to calculate how many milliliters per hour. So I'm trying to calculate how many hours, and then following dimensional analysis, that's just what tells me where to put it. So this becomes 20 hours. So that's step one. Do we know how long it takes? 20 hours. If we start Monday at 8 a.m., remember that's 0800. So if you're in military time, if it were 24 hours, right? So this is Monday. Let's just say Monday at 0800. So Tuesday at 0800 is 24 hours later, right? So I just take the difference. I take away 4 hours. So my answer should be Tuesday at 0400 or at 4 a.m. So there's a couple, I think a couple of different ways to answer this question, but that's how I would set that up. Okay. And there are some nuanced questions where like you have to calculate to the quarter hour, to the you can certainly do that, but I haven't seen a lot of those questions, so I don't know that you necessarily need to worry about that too much. So. All right. So I'll be back on for 2:20, 2:30 this afternoon, or this, I guess at this later this evening at 5. And then I'm also here on Thursday, same times for you guys, 1:15 and then 5 o'clock. Yeah, so complex question is basically the Heparin protocol. Complex question just means you have to do more than one calculation. So complex question would be going from like pounds to kilograms and then multiplying that kilogram weight by to calculate the bolus dosage strength. So that would be an example of a complex question. Yeah, you're welcome. All right. So if you have any other questions, please feel free to email me. Or like I said, I'll be back on for 2:20, 2:30 at 5 o'clock. You're welcome. And then this will be posted up on YouTube later today or tomorrow.